Hello everyone. Today this is the second video of system design with the multi-threading series. In the previous video we have understood what is the difference between concurrency and multi-threading. Let me revise you for the ease of your understanding. Not multi-threading. What is the difference between concurrency and parallelism? Okay. So the difference lies in the fact that concurrency is handled by a single CPU core and the parallelism is handled by the multiple CPU cores. It can be explained in a similar analogy like concurrency is actually handling multiple things at once and parallelism is actually doing multiple things parallelly. Doing things parallelly is known as parallelism, and concurrency, you are handling the multiple thing at once. Okay, so now in this today we are actually going to talk with the very interesting concept, producer consumer problem. Okay, and what actually the problem is, I have created another video in which I have explained what is the observer design pattern. Okay, in the behavioral design playlist you can check this video. We are going to talk about the producer and consumer problem. Okay, so let's say इसको थोड़ा हिंदी में समझते हैं कि आप खाना खाने बैठे हैं, ठीक है, एंड लेट्स से you have a capacity to eat 5 chapati. Okay, and currently you are able to eat it so fast. After eating 2 chapatis, the producer cook is actually not fast enough to give you those chapati. Okay, so at that point in time you have to wait. Okay, because you need to eat 3 chapatis now, right? And so you need to, as a consumer, you need to wait for the producer. Okay, let's say if you are a cook and you are fast enough to make the 5 chapatis, but your consumer or your guest is actually now currently he only ate 1 chapati, then you need to wait that his remaining chapati should be consumed by him, and then you can serve the next 3 chapatis. So this is the similar analogy. Without wasting any time, let's see this problem, how we can create the threads, how we can solve this problem. Like producer, at which point in time producer needs to wait, at which point in time consumer needs to wait. Okay, so let me share my screen, just a minute. Yeah, that's it. All right, yeah, now it's visible. So let's say you have I have already created a class which is known as shared resource. Okay, and this class, let's say it contains a queue of integer. Okay, and let's say this shared resource. Okay, so this queue is actually bounded queue. Let create a int which is like size. Initially the size will be equal to 0. Let me create a shared resource as a constructor. Let's say the capacity by at which producer can produce the item is with some size. Let me define this size. Okay, alright, size has been defined. Now okay, now what would be done? Producer will be going to add the item, consumer is going to consume the item. Okay, so let's add something called as producer add item, and the item will be like integer of item. Okay, so where those item is going to add, the shared resources dot add item. That's it. Now we should have another method like some consume the item. Okay, consume. All right, and when you are going to consume, then shared resource dot poll. Right, now if we are going to execute this code in a single threaded environment, okay, if there is only one producer and only one consumer, then it works fine. But as we are talking about the multi-threading, it should not work. So at one point in time, we should add, in order to work it in a multi-threading environment, we need to add some keyword like synchronized. Now it should be like no two threads can access this my add method and consume item. At one point in time, it will be not going to be this is my shared resources, a critical section of the code. It can be shared by the one thread at one point in time. Okay, that's why that is the use of synchronized keyword here. Now let's actually try to solve this problem. So let's say if the size of the item is equal to shared resource dot size, let's say if the maximum limit has been reached, then you have to actually wait for the consumer to consume the item. Let's say system out wait for consumer to consume the item, and then you have to wait it. Right, once you are adding this method, you have to add some interrupted exception either in the try catch block, or you need to throw this exception. Okay, and yeah, if the shared item is being going to added, then you need to tell item has been added, notify consumer. All right, and then this will be notified. Similar fashion, when should we wait? If the shared resources is empty, then you need to actually wait for producer to produce the item. Otherwise, you will not be able to get the item for your consumption purpose. Correct? Then wait for, instead of consumer, just change it to producer. Okay, to produce the item. All right, and then we need to wait here. All right, and then add this inside the message interrupted exception, throw it, and once you are going to poll it, poll the item, it means that the size is now basically less than your shared resource size. Okay, then just notify the consumer, item has been consumed by the consumer, notify producer. Great, not producer, yeah, item has been consumed, notify producer. All right, and then we need to notify. Okay, so this is my class, this is thread safe. The thread safe class has been created. Now let's try to create a actual threads. Okay, so let me go inside the main class. Let me create shared resource is equal to new shared resource. Let's create a size. Okay, now let me create one thread of producer will be equal to new what we can do that, new thread, and instead of shared item. Okay, and let's try to run this program. Let me just create a, let's surround with the try catch. Great, let me try to run this program inside yeah, the loop. Let's create actually 6 items. Okay, and now your method will be like sorry, This is for loop and this is done. Alright, let me copy this same code, and that will be the like consumer, and shared resource will be like what, add item. Currently it will be going to add the item, and now the consumer will actually consume the item. So this method will be called, so shared resource is actually this object has been shared with the different threads, producer thread and consumer thread. There are two threads. They will actually be going to run 6 times, and at one point in time we have 3 items to produce. So whenever first time whenever the 3 items is going to be added, then it needs to wait for consumer to consume. Whenever consumer consumes all the item, then producer then it will be notified to the producer like to produce the item. Okay, now let me start this thread, let's run it. Exception, great. Where is the exception? Shared resource, because this shared resource is null. Great. So why this is null? Because I have not initialized it. So what I can do, I can initialize it here. Okay, let's see if it runs or not. Great. So you can see that the 3 item has been added. Then at this is the unbounded queue. We have keep a size over here. Once they reach the size, it has to wait. Then it has been wait. So wait for consumer to consume. Now consumer is consuming the item. Then once it is all the item has been consumed, then he is to wait for this consumer. So this is the problem, and this is the example by which I showed you how we can solve the producer consumer problem in a multi-threaded environment. Hope you like this video. Thank you.